Hi, folks. We're going to take a look at page 139, number 9. So they give us this function here, which represents the price of a stock in dollars, and it's measured in the number of years from 1999. So it's trying to predict the value of the stock after the year 1999, and they want us to determine when the price, based on this model, will be more than $90. Okay, so what we have here is a polynomial inequality because we want to know when the price of this stock, which is given by 0.5 t cubed minus 5.5 t squared plus 14t, is going to be greater than $90. All right, so this is what we're trying to solve. What we need to do here is go through our algorithm for solving an inequality. Okay, so sorry, just have to adjust that there. So we know that the first step is to bring everything to one side of the inequality. So I'll bring the 90 to the other side. So here I've got 0.5 t cubed minus 5.5 t squared plus 14t, and then minus 90. And so now the goal is to hopefully factor the left-hand side and use a graph to solve this inequality. Now, I don't think this is going to factor by grouping. Pretty certain it won't. The other thing is I'm not a big fan of having this 0.5 here, especially if I'm going to be working with a calculator, which I won't be. We're going to take a look at an alternative. What would just make this easier to work with, even though it'll make the numbers a little bigger, is why don't we just multiply both sides of this inequality by 2, which we know we can do, because if we're multiplying both sides by a positive number, the inequality is maintained. So I'm going to multiply the left side by 2, so that's just going to leave me with t cubed. This is going to be minus 11t squared plus 28t minus 180. And here, obviously, 0 times 2 is 0. Okay, so we just have something a little more familiar here. So what I'm going to do is start with the factor theorem, because take a quick look. If I take out the t squared, I'm going to be left with t minus 11. I don't think I'll be left with t minus 11 here. In fact, I certainly won't if I try to factor anything out. But instead of using my calculator, because these are pretty big numbers, I'm not quite sure how many I'm going to have to do. I suggested that you start looking for online tools to make these things a little faster. Okay, so what I'm going to do here is in Google, I'll just put in function calculator. Essentially that's what I'm trying to look for. And as I suggested, Symbolab is often a really good one to use. All right, so what I'm going to do is I'm going to put in my function. So I'll have to use x here. So it'll be x cubed. That's minus 11x squared and plus 28x, and then minus 180. And I think here if I use a semicolon, I can start calculating f at whatever I want. So let's say I want f at 1. Okay, and what it does here is it calculates f at 1. And of course, the important thing for me is that it's not equal to 0. So I'm just going to keep going. Okay, f at negative 1. Okay, again, look here. We'll see that it's not 0. So I'm just going to keep going till I get 0, and hopefully I do. So f at 2, not 0. Negative 2, still not 0. I'm glad I did this with the computer because this would have taken me a really long time to do this by hand. Okay, 3 doesn't work. Negative 3 still doesn't work. So 180 is divisible by 4. So let's try 4. Still doesn't work. Negative 4. Still doesn't work. So you see how this can be very tedious if I had to do this with a calculator. Now you wouldn't get this on a test, but hey, on a homework question, who's to say that you might not get something with this many factors to check? So we're still not there. I'll keep going. You can almost fast forward this until I get to something. I don't think it's divisible by 7, so I can skip that. I actually don't think it's divisible by 8, but since I'm doing it on the computer, I'm just going to check it. Not going to bother even checking whether it's a factor or not. Okay, so we're still not there. So there's f at 9. Still not there. Negative 9. Still not there. Right, 10. Oh, and there we go. Finally, f at 10 is equal to 0. Okay, so that took a while, but we got there eventually. So here, I'll do this work on the side. So f at 10, or I guess I should, yeah, I'm not going to call this p because p is equal to this function. So I'll consider this thing f at 10 is equal to 0. And of course, what does that mean? It means x minus 10 is a factor. All right, so now I'll do my long division. So I've got 1, negative 11, 28, not my long division, of course, my synthetic division. And here I'm dividing by x minus 10. So here we have 1, that's 10, that's negative 1, it's negative 10. So that is going to be 18. 10 times 18 is 180, and that works out perfectly. So it means we definitely did get a factor. And so now that means I can rewrite the left-hand side of the equation as t minus 10. That was the first factor I found. And then the quotient when I divided is t squared minus t plus 18. And I want to know when that's greater than 0. Okay, so I want to find the zeros here. This, though, does not look perfectly factorable. So I know that if I'm looking for my x-intercepts, I know I've got 10. And to find, or sorry, I should call these my t-intercepts, is 10. And the other ones, I'll have to use the quadratic formula. Okay, so negative b, so negative 1 is just 1 plus or minus square root of b squared. So negative 1 squared is 1 minus 4 times a, which is 1, times c, which is 18, all divided by 2a, so 2. And right away here, I can see that this is going to be a negative number. So that means there's only one x-intercept to this cubic, which we know can happen. So now we'll use this information to sketch the graph. Okay, or actually just sketch where it's positive and negative. So the only x-intercept is at 10. Okay, and I know it's a cubic. I have to look at this cubic here. This is the one I'm determining is greater than 0. It's a cubic polynomial with positive leading coefficient. So that means it has to start at negative infinity, end up at positive infinity. So it'll look, it doesn't matter exactly what it looks like, but I know that it'll cross only at 10. And here it's crossing from negative to positive. So when will this be priced at more than $90? It looks like after 10 years. So it'll be greater than $90 after 10 years. That is, since they actually told us when we're measuring from, 1999. So that is from 2009 on. All right. Now, whether this model is, accurate for more than 10 years, or it's hard to tell how accurate this model is. This is sometimes a type of problem that you solve with stocks because, computer might be set to sell a stock once it reaches a certain amount. So you need to know when you expect that to happen to make a prediction as to what the portfolio will be worth at once it reaches $90. Okay, so again, just to repeat, they give us our price function. We want to solve the inequality when it's greater than 90. Step 1, bring everything to one side. Step 2, do the factorization. In this case here was a very long factor theorem, but by using technology went a lot quicker. And once you get to quadratic, remember that you can use the quadratic formula to find the remaining x-intercepts. In this case here, there actually weren't any. From there, sketch your graph using your x-intercepts and your sign of the leading coefficient and the degree, and then you can read your answer straight off the graph. All right, that is it for this one.